Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to talk about magnitude of a vector, all right? So I've introduced this concept of magnitude earlier, but in this video, I'm going to discuss it in detail, all right? So that you can further understand or solidify the concept you already know already. Okay, so before I proceed, don't forget to like, share, and subscribe. Don't forget to click notification bell so that when I post new videos, you'll be the first person to know. Now, when we talk about the magnitude of a vector, it's basically the length of that vector, also known as the modulus. Some textbook will call it the absolute value of the vector. And it's also usually written with this sign here. So maybe the vector is A, the absolute value of the magnitude of the vector is going to be written as like this with two slashes. Is that making sense? So that's how you write magnitude of vector. So I'm going to show you how to find the magnitude of a vector. And before that, I'm going to just write down what I just said here. So the magnitude of a vector is basically the length, okay? The magnitude of a vector is the length of the vector. Okay. Um, so it is also known as, okay, so you can, some people call it the modulus, so you can call it the modulus. Some call it the absolute value. So you could see any of this name, is exactly the same thing. Okay. So modulus of a vector, or you can put it like that, modulus of a vector, absolute value of a vector. Okay. So that is what you can also find as well. So, and also, what I said as well is that the magnitude of a vector, so how do you write it? So if, for instance, we have A, so the magnitude of a vector A, okay, so it's written as, so you write it like this. So that's how you write absolute values. Is that making sense? Or the magnitude, you write the magnitude using the absolute value symbol, all right? So there are 3 steps to find the magnitude of a vector. So I'm going to show you the 3 steps now. So how do you then find the magnitude of a vector? All right, there are 3 steps to do that. So there are 3 steps to find the magnitude of the vector. So the first thing you have to do, you have to first identify the components. Then when you've identified it, you then have to find the sum of the squares of each of the components. Then you now take the square roots of the sum that you obtained from step 2. So the first thing, you have to identify the components, okay? So remember we talked about it can be either 2 components or you can be 3 components. Then the second part is that after you've done that, you then have to then find the sum of the squares of each of them. So find the sum of the squares of each of its components. Then after finding the sum, the next thing you then do is to then take the square root of the sum you obtained. Okay, so you now take the square root of the sum you obtained. All right. So therefore now the formula now will now be, so first thing, you have to now do, so that's the formula. Okay, so if, for instance, you have a two-component vector, let's say V is a two-component vector of X and Y, for instance. So the magnitude of V is going to be equal to the square root of what? X squared plus Y squared, okay? Now, but if V, all right, is a three-component vector, so it's like X, Y, or Z, okay? Then the magnitude of V is going to be square root of X squared plus Y squared plus Z squared, okay? And just to remind you that for a two-component vector, you can also write it in this form. So you can write a two-component vector in this form, and you can write a three-component vector or as well in this form as well, okay? So just so you know, so that means you can write V as a two-component vector like this, and as a three-component vector like this. So it's exactly the same thing, all right? Good. Now the next thing is that for a vector, when one of its endpoints is at the origin, the other endpoint is x and y. So you can also find the magnitude. So that means if you have component vector, but in this time you have the maybe you have the coordinates. So that means what I'm trying to say is that for the first one, okay, you just have the vector, you had v, which is x and y. And for the second one, you have maybe you have a vector v, which is x, y, and z. Okay. Now, what I'm saying is that what happens now if you have maybe you had a vector, all right, in which one of the endpoints here is maybe the origin, and the other endpoint here maybe is let's say x and y. Are you seeing the difference? It's going in this direction. Or you have a vector in which at this endpoint here, you have x1, y1, and at this endpoint here, you have x2, y2, and it's a vector. So how do you now find the magnitude for this type, okay? So what do you do? So the first thing is that, so the third one is that for a vector v, okay, when one of its endpoints is at the origin, okay? And the other endpoint is at x and y. Okay? So for instance, you have something like this. So that means if we give an example, so you have a vector v, okay? But the first endpoint is 0 and 0, and the second endpoint is at x and y, okay? So how do you find the magnitude for this? So the magnitude of v will now be equal to square root of x minus 0 squared plus y minus what? 0 squared. Are you seeing it? Which is the same thing as saying square root of x squared plus y squared. Are you seeing it? So if it's at the origin, it's the same thing as x squared plus y squared. But if it's not at the origin, so if, for instance, the vector is not at the origin, so if, for instance, the vector v, okay, with endpoints, at x1, y1, and x2, y2. Okay? Now, so that means we have a vector like this. So this is the vector v, but this time here is x1, y1. Okay? While this point here is x2, y2. Now, how do you find the magnitude for this? The magnitude for this is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 what? All squared. So that's like the 4 ways in which you can get the 4 formulas for this. All right. All right. So you'll be saying Mr. Terry has been talking a lot. So let's solve some questions now. Okay. So let's pick an example. Okay. So number one, we're told to find the magnitude of the vector A is equal to, we have it as 1, 2, and 4. Okay? So now for this, now it's very easy. We can say the magnitude of A is going to be equal to the square root of 1 squared plus 2 squared plus 4 squared. So 4 squared is 16. 16 plus 4 is 20. 20 plus 1 is 21. 21. That'll be square root of 21. So therefore, we can now say magnitude of A is equal to the square root of what? 21. Now, what about if it was a two-component vector now? So let's pick this example here. Number 2, we're told to find the magnitude, okay? Now, in this case, it's going to be a two-component vector of u, which is equal to 2, 5, all right? So remember, I always tell you I prefer to write this in the column form, all right? So now we can now say the magnitude of u will now be equal to the square root of 2 squared plus 5 squared. And that will give us 25 plus 4 will give you 29, square root of 29. So therefore, the magnitude of u is going to be equal to the square root of what? 29. So that's how you find that. All right, let's pick an interesting one. Let's say we have number 3 now, okay? Let's say we have number 3. So we are told that if A and B are given by 5 and minus 3, okay? And minus 2 and 1, okay? We're now told to now find the magnitude of AB. Okay? So we know A, so that means here we know A to be equal to 5 minus 3, okay? And we know B is equal to minus 2, 1. So if you remember, when you have 2 points, so it's similar to when I told you that you have x1, y1, and you have x2, y2, okay? So now we have something like that, so we can now find the magnitude of AB now. So the magnitude of AB is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 what? Squared. Okay. So in this case now, we can now say this is x1, y1, and this is x2, and this is y2. So it's going to be equal to square root of -2 minus 5 squared plus y2, 1 minus -3 what? All squared. Okay? And when you press this in your calculator, it should give you around square root of what? 65. Okay? All right. So that will be that for that. All right. So maybe you can go to the textbook and pick more questions to solve. So basically, it's still the same principle. The magnitude is just the square root of x squared plus y squared. If it's a three-component, x squared plus y squared plus z squared. If it has 2 points, or the vectors are having 2 points, or there are 2 endpoints. So you're going to be x2 minus x1 squared plus y2 minus y1 squared. All right. All right, thank you very much. And that is that for that. The next video we're going to be talking about, multiplication of vectors. So how do you multiply vectors? Now, this is different from scalar multiplication. So this is when you have two vectors together and they are multiplying. So we're going to talk about things like the dot product, the cross product, and the rest of it. So it's important that you subscribe and click notification bell so that when I post the next video, you'll be the first person to know. So if you have any question, please do let me know. Send me an email and I'll get back to you as soon as I can. All right. So see you soon.